Hi everyone, this is Arvind from Mindmajix, and today I welcome you all to this amazing session on Azure Data Engineer interview questions. So guys, in this particular video, we will be covering roughly around 30 questions, and all of these 30 questions have been divided into three categories. The first set of questions, like the first 10 questions, are for the freshers or the beginners. Then we have the next 10 questions, which are meant for the intermediate people, and the last 10 questions are for the advanced folks. Okay, so this is the agenda for today's video. And before moving ahead, I want you guys to subscribe to Mindmajix YouTube channel and also hit that bell icon so that you never miss an update from us. So without any further delay, let's get started with our first question. So the first question says, what is Azure Data Factory and why is it used? So guys, Azure Data Factory or ADF is a cloud-based ETL. ETL is nothing but extract, transform, and load, an ELT service that helps you move and transform data from different sources to destinations. So it is widely used for building data pipelines that integrate data from on-premises databases, SaaS applications, and cloud storage. Just to give you an example, so you can use Azure Data Factory to pull sales data from an on-premise SQL server and load it into Azure Synapse Analytics for reporting purpose. So basically, Azure Data Factory is a cost-effective and serverless. That means you don't need to manage any infrastructure. The next question is, what are the different types of integration runtimes in Azure Data Factory? So guys, there are basically three types of integration runtimes or IR in Azure Data Factory. And as you can see on the screen that they are Azure IR, self-hosted IR, and Azure SSIS IR. So if we talk about Azure IR, so basically this is used for data movement within the Azure infrastructure. If you talk about the self-hosted IR, so they are used to connect on-premises data sources securely. And last but not the least, the Azure SSIS IR, it's used to run the SSIS packages in Azure. For example, if you want to copy the data from an on-premise SQL server to Azure blob storage, so here you would use a self-hosted IR. The next question is, explain a real-time scenario where you used Azure Data Lake. So let's suppose there's a retail company storing daily transactions from the POS systems across 1000 stores. Now these retail company can use Azure Data Lake to centralize the raw data. Over here, the data is ingested into Data Lake Gen 2, either in the JSON or the CSV format, and then it is transformed with databricks before being consumed by the Power BI for dashboards. So over here, the data lake acts as a single source of truth for structured and unstructured data. So guys, this scenario was just an example. If you're actually asked these kind of questions, like explain a real-time scenario, so over there you have to, like if you have experience in working, like there's a project or these kind of things. So even those examples are relevant for these particular kind of questions. Okay, so now let's move ahead and discuss the next question. So the next question says, what are the main differences between Azure Blob Storage and Data Lake Storage Gen 2? So guys, both are the storage services, but Data Lake Storage Gen 2 is built on top of the Blob Storage with additional capabilities. So it supports hierarchical namespace such as folders and directories, and which makes it easier for big data analytics. If you talk about the blob storage, so it is good for general purpose file storage, while Data Lake Gen 2 is better for the advanced analytics. For example, let's consider that there's a company and this company might store images in the blob storage, but on the other hand, large log files are stored for Spark processing in the Data Lake Gen 2. So guys, let's move to the next question. So in a real-time project, how do you handle incremental data loads? So incremental loads means only loading new or changed data instead of reloading everything. So in Azure Data Factory, this can be achieved using the watermark columns like the last modified date. For example, if you are moving the order data daily, so you can filter only records with last modified date and the last run date. So basically, this procedure saves the cost and improves the pipeline performance. The next question is, what is PolyBase in Azure Synapse Analytics? So PolyBase is a technology that allows Synapse to query data directly from external sources like the blob storage or the data lake without importing it first. For example, you can query a CSV file in the data lake using a TSQL as if it were a database table. So this reduces the data movement and speeds up the analysis. The next question is, so guys, in the actual interview as well, there will be, apart from the theory questions, there will be a lot of scenario based questions as well. So by asking the scenario based questions, the interviewer wants to test how much of the practical knowledge and skills do you have related to Azure data engineering. So guys, this particular question is a scenario based question, and the question says, how would you design a pipeline that loads data every hour from the multiple APIs into Azure SQL database? So first and foremost, what you would do is you would create an Azure Data Factory pipeline with a copy activity that calls the REST APIs every hour using a trigger. So the raw API response would then be stored into a data lake for audit and then transformed using the mapping data flows before being loaded into Azure SQL database. So this ensures reliability and reusability in case of APIs fail or the schema changes. The next question is, what are the linked services in Azure Data Factory? So linked services define the connection to external data sources such as the databases, APIs, or the storage accounts. So think of them like the connection strings. For example, if your pipeline needs to move data from the Azure blob storage to SQL Server, for that you would create two linked services. So one for the blob and the other one for the SQL Server. The next question is, how do you handle schema drift in a data pipeline? So guys, schema drift happens when the source data schema changes unexpectedly. So in Azure Data Factory, what you can do is you can use mapping data flows with schema drift enabled so that the new columns are handled automatically. For example, if a new column discount is added in the sales dataset, the pipeline will still work without breaking. The next question is, what is the difference between Azure Synapse Analytics and Azure SQL Database? So guys, Azure SQL Database is designed for the transactional workloads like the OLTP, while Synapse Analytics is for the analytical workloads like OLAP. SQL Database is used for the applications with frequent inserts or updates, whereas Synapse is optimized for running complex queries on large volumes of data. For example, an e-commerce website uses SQL database for customer orders, but Synapse for analyzing the purchase trends. So guys, with this, we have covered the beginner level questions or the questions that are meant for the freshers. And now the next 10 questions are for the intermediate people, like those people who have at least 2 to 3 years of experience working in the domain of Azure data engineering. So now let's move to the next question. So the next question says, how would you migrate an on-premise SQL Server data to Azure in near real time? So guys, first and foremost, what you need to do is you need to start with an initial bulk load using the Azure Data Factory. And over here, you will be using the self-hosted IR or Azure Database Migration Service to seed the target in Azure, ensuring schema compatibility and indexes are in place. For near real-time changes, what you can do is you can enable change data capture or CDC on the source SQL server to capture the inserts, updates, or deletes, and then stream those changes to Azure using the technologies like the transactional replication, change tracking, plus ADF incremental pipelines. Or you can also use a log-based connector that pushes event hubs or Kafka. On the Azure side, what you can do is you can use a lightweight consumer to apply the CDC events or the upserts into Azure SQL or a Delta table. Over here, what you need to do is you need to also ensure idempotency so that the duplicate events do not corrupt the targets. You can also consider latency, ordering, and transactional boundaries. Some business scenarios require strict ordering, which affect the architecture choices. For example, a CRM system might use the transactional replication to synchronize critical customer records into the Azure SQL for near real-time reporting, while the large-scale events streams may use the event hubs plus Databricks for eventual consistency. The next question is explain how Azure Databricks fits into a data engineering architecture. So guys, Azure Databricks is a managed Spark platform that excels at a large scale data processing, ETL, interactive analytics, and machine learning. So it is commonly used as the heavy lift compute layer in the modern data platforms. Databricks integrates tightly with the ADLS Gen 2, Delta Lake, and a variety of ingestion sources, enabling efficient transformation, streaming processing, and model training within notebooks or scheduled jobs. So the common roles for Azure Databricks include cleansing and aggregating raw data into curated Delta tables, building feature pipelines for machine learning, and performing ad hoc analytics that require distributed compute. Databricks supports Delta Lake, which brings ACID transactions, time travels, and efficient upserts to data lakes critical for production grade pipelines. For example, raw clickstream logs into ADLS are read into Databricks, deduplicated, enriched with reference data, and returned into partitioned delta tables for reporting and modeling. The next question is, what are the pipelines, datasets, and activities in Azure Data Factory? So guys, you must be seeing a lot of questions around the Azure Data Factory concept. And guys, believe me, if you are into Azure data engineering role, Azure Data Factory is a very crucial topic. So that is the reason you will see a lot of questions around this particular topic. So over here, you have to explain what are pipelines, datasets, and activities in Azure Data Factory. So if you talk about a pipeline, so pipeline is a top-level workflow container that groups related activities to implement an end-to-end data integration scenario. So basically, the pipelines provide parameters, control flow, and retry policies. If you talk about dataset, so this describes the structure and the location of a data, like the table, file path, or a folder pattern, and acts as a pointer used by the activities. Basically, datasets do not contain the data themselves. Now, if you talk about the activities, so an activity is a single action inside a pipeline, and it basically represents a unit of work. Activities can be composed with the control flow, constructs such as if condition, for each, wait, and execute pipeline to build complex orchestrations. The next question is, let's suppose there's a scenario, and in this particular scenario, your pipeline failed due to a timeout error while connecting to a SQL database. So how do you troubleshoot this particular situation? So first and foremost, what you can do is you can begin by inspecting the Azure Data Factory activity run details and diagnostics logs to capture the exact error message, stack trace, and the timestamp. So this narrows down whether it's a transient network glitch, authentication, or a resource saturation. The next step is to check the networking. So over here, you have to ensure that the firewall rules and VNet service endpoints are configured correctly. And you also have to verify the integration runtime being used has the network access to the database. So if at all you are using a self-hosted IR, you need to confirm that the agent service is running and healthy. On the database side, you have to check the resource metrics to ensure that the SQL is not overloaded, and the long running transactions or blocking could also cause the timeouts. Next, you have to tune the connection and command timeout settings in the linked service if appropriate, and implement the retry policies in your pipeline to handle the transient failures. So these are the some of the steps that you can follow in order to troubleshoot this particular kind of situations. The next question is, how do you optimize performance in Azure Synapse Analytics? So performance tuning in Synapse starts with choosing the right distribution strategy, hash distribution for large join keys, and replicated tables for small dimension tables to avoid shuffles, and round robin when no clear key exists. Apart from that, what you can do is you can also use column store indexes for large fact tables to improve the IO efficiency on analytics queries, and ensure proper partitioning to allow the partition elimination for date ranged queries. Apart from that, you can also monitor the query plans and statistics, Stale statistics can cause the poor plans, so keep them updated and consider the result set caching or materialized views for frequent run aggregations. Next, you can also tune parallelism and resource allocations so that you are able to scale your data warehouse units during heavy loads and adopt the workload management by isolating the heavy ETL into separate tools. The next question is, how do you handle slowly changing dimensions or the SCD in Azure Data Factory? So slowly changing dimensions or the SCD track changes in dimension attributes over time. So the most common approaches are type 1 and type 2 and type 3. In Azure Data Factory, mapping data flow can implement SCD patterns by comparing the incoming records to the target keys, generating inserts for new members, and optionally closing the existing records for type 2 and by setting an end date or is current flag. So for big data sets, what you can do is you can use an efficient upsert or merge patterns. For example, databricks merge into delta tables so that you can perform the record level updates without rewriting the large tables. So for type 2, the typical steps are, first you have to detect the changes, then set the previous record's end date and insert the new version with a start date and maintain the surrogate key for joins as well. The next question is, what is Azure Stream Analytics and where would you use it? So Azure Stream Analytics or ASA is a fully managed real-time analytics engine designed to process high throughput streaming data with SQL-like language for windowing, aggregation, and pattern detection. It ingests events from event hubs, IoT hubs, or blob storage and can output to multiple sinks like Power BI, SQL database, or Azure functions for downstream actions. ASA is ideal when you need low latency processing with simple to moderately complex queries. Examples include real-time telemetry monitoring, anomaly detection, or live dashboards. ASA supports sliding, tumbling, and hopping window constructs, which are useful for computing rolling aggregates like per minute averages, and it can integrate with ML models for scoring. Next question is, how would you secure sensitive data like credit card numbers in Azure? So securing sensitive data requires layered controls. Over here, you need to encrypt data at rest and in transit, restrict access via identities and network controls, and apply field level protections. For this purpose, what you can do is you can use Azure Key Vault to manage the keys and secrets, enable transparent data encryption or TDE for databases, and consider always encrypted or column level encryption for highly sensitive fields so even DBAs cannot read the raw values. Apart from that, what you can do is you can implement dynamic data masking or create a masked views for reporting the users so that downstream systems can see only partial values and use role-based access control and managed identities to ensure the least privileged access for services and users. Apart from this, network controls like private endpoints, service endpoints, and firewall rules reduce the exposure, and audit logs should be enabled to track the access and modifications for compliance. The next question is, what are the delta tables in Databricks and why they are useful? So basically, delta tables are transactional storage layer built on top of file formats that add the transaction log, schema, enforcement or evolution, ACID guarantees, and time travel for data stored in data lakes. So the core benefit is that you can reliably perform inserts, updates, and merge operations at the scale without locking or risking the inconsistent reads. So this makes production ETL and ML pipelines far more robust. So Delta's transaction log enables the version queries to inspect the historical data state and supports the compaction and optimization operations to improve the query performance. The next question is, let's suppose there's a scenario, and in this particular scenario, the interviewer wants to understand how would you implement data partitioning in Azure Data Lake for better performance. So over here, what you can do is you can use partitioning. Basically, partitioning is organizing files into folder paths based on commonly filtered keys. Over here, you need to choose partition columns that align with the query patterns like the date ranges that are most common, and avoid overly fine-grained partitions that create many small files because that causes the metadata overhead and increased task scheduling costs. Apart from that, you can combine partitioning with appropriate file sizes like few hundred MBs to a few GB per file depending upon the workload, and use the periodic compaction jobs to merge the small files. Apart from this, we can also use Hive style partitioning or partition metadata that your compute engine understands, so Spark or Synapse can skip irrelevant folders efficiently. For example, if most analytical queries filter on date and region, over here you can partition by year, month, day, and region to limit the reads to only relevant slices. Also, have an archival policy to move old partitions to coolest storage tiers so that you can optimize both performance as well as the cost. So guys, with this, we have covered the intermediate level of questions for Azure Data Engineer. And now the next 10 questions, question number 21 to 30, we will be covering the advanced questions for Azure Data Engineer. So the next question is, you need to design a modern data platform on Azure for a bank. So what services would you use? So guys, again, this is a scenario based question, and over here you need to answer this question carefully because this is a scenario based question, and these kind of questions, like if you answer them successfully in the actual interviews, so that is going to create a very good impression of yours on the interviewer, and basically the interviewer will also understand that you have the practical skills and not just the theoretical knowledge. So in this particular question, so guys, for a bank where security, compliance, and reliability are of utmost importance, what you can propose is you can propose a layered architecture. Now, what do you mean by a layered architecture? So over here, ingestion can be done via event hubs and Azure Data Factory for batch or stream capture, raw landing in ADLS Gen 2 with strict ACLs, processing in Databricks using data lake for transformations and feature engineering, storage of curated analytics in Synapse, dedicated pools for fast BI queries, and Power BI or a BI layer for visualization. Security layers include private link or private endpoints, VNet integration, or key vault for secrets and key management, RBAC and ACLs, and Purview for data classification and lineage to meet the compliance. Apart from that, what you can do is you can use managed identities for service authentication, implement encryption at rest or in transit, and establish DR with cross-region replications and failover groups for databases. For ML or the real-time scoring, deploy models in Azure ML or Databricks, serving with monitoring and explainability. For governance, you can include Purview Plus, auditing, and policy guardrails via Azure Policy. And finally, you can incorporate CI/CD pipelines, staging and user acceptance testing environments, and robust monitoring or alerting so that you can operate at a bank grade SLAs. The next question is, how do you manage the data lineage and governance in Azure? So over here, what you can do is you can start by onboarding key data sources, running scans to automatically classify the data, and building a business glossary so that the stakeholders agree on definitions and owners. You can use Purview lineage and classification to answer questions like which pipeline loads this table or which downstream reports consume this dataset. So all of this is critical for audits and impact analysis. Apart from that, you can also combine Purview with access controls, RBAC, and tagging in Azure Data Factory or Synapse to enforce the governance policies discovered during the scans. The next question is, let's suppose your Synapse queries are slow due to skewed data distribution. So how do you fix it? So data skews basically occurs when one or few of the values dominate a distribution key, causing the uneven compute work across the nodes. So here, first and foremost, what you can do is you can start by identifying the skewed key through the query plan analysis and distribution statistics. Over here, the remedies can include choosing a different distribution column that better balances the data, switching to round robin when no good key exists, or using the replicated tables for small dimension tables that are frequently joined. Apart from that, you can also apply salting, which is nothing but append a synthetic salt value to the distribution key to spread hot partitions and then adjust joins accordingly. But salting complicates the queries and ETL logic, so you have to use it very carefully and judiciously. Another approach is to pre-aggregate or Bloom filter the skewed data or break the large joins into staged smaller joins to reduce the shuffle. The next question is, how would you implement CI/CD for Azure Data Factory? So implementing CI/CD by connecting the Azure Data Factory to a Git repository so that the developers work in feature branches and changes are version controlled. Here you have to use branching strategies such as the collaboration branch or publish branch and parameterize the linked services for environment specific values. And you have to store the secrets in key vault referenced by ARM templates rather than embedding the secrets. So whenever you're ready to promote the changes, you can publish the factory to generate the ARM templates, which can be deployed through Azure DevOps or GitHub Actions pipelines. And these pipelines should run automated validation tests, deploy to UAT, and run the integration smoke tests, and then promote to the production after the approval. Over here, we can automate the environment specific parameter substitution and safe rollback strategies by keeping a previous ARM artifacts. For example, a CI pipeline builds and runs unit tests for data flows, while a CD pipeline deploys ARM templates to the staging resource and triggers the integration tests before manual or automated promotion. So this approach creates reproducible deployments, audit trials, and safer production changes. The next question is, how would you implement real-time fraud detection using Azure services? So a robust real-time fraud system ingests transactional events via the event hubs, or the IoT hub uses stream analytics or databricks, structured streaming for low latency feature computation and rule-based detection, and leverages a trained machine learning model for probabilistic scoring. So here the online features can be stored in a fast key value store like the Azure Cosmos DB or the Redis for quick lookup during the scoring, while longer term features are computed in Databricks from the Delta tables. So when a suspicious score exceeds a threshold, you can push a message to an alerting system to create an investigation ticket and optionally block the transaction via a decision service. So architect for both precision and latency, simple rule-based checks can be executed very fast, and heavier machine learning scoring can run in parallel or be approximated by lighter models for the initial stage. For example, a pipeline might compute real-time velocity features in stream analytics, apply a rule set, and then call a Databricks endpoint for machine learning scoring before taking action. Over here, the detailed events are persisted to the lake for post-incident analysis and model retraining. The next question is, what are the best practices for cost optimization in Azure data engineering projects? So guys, cost optimization requires both architectural as well as the operational measures. So right size compute, leverage auto scaling and spot instances where tolerable, and reserve capacity for predictable workloads to gain the discounts. So to optimize the storage cost, what you can do is you can use lifecycle policies, compressing data, and avoiding small file sprawl through specific periodic compaction. For interactive or ad hoc workloads, you can consider serverless options to avoid standing capacity costs and implement the query and the data partitioning strategies to reduce the scanned data volume. Apart from that, you need to continuously monitor cost using the Azure Cost Management and set the budgets or alerts, instrument pipelines to track the compute or IO per job so that you can optimize the expensive workflows. The next question is, how do you ensure high availability and disaster recovery for Azure SQL database? So Azure SQL database provides built-in high availability and backup features, but for robust DER across regions, you should configure the active geo replication with failover groups, which creates the readable secondaries in another region and supports the automatic or manual failover. Over here, you have to complement the replication with automated backups and retention policies that meet your RTO or the RPO objectives, and regularly test failover procedures to ensure that the applications correctly reconnect and handle transient states. For multi-region availability, Consider zone redundant configuration and use read scale out for load distribution of read-only workloads. Also, you have to plan the DNS and the connection string strategies so that the application failover is seamless and includes runbooks for post-failover tasks like repointing downstream ETL and updating the firewall rules. The next question is, how do you handle the data quality issues in Azure data pipelines? So data quality should be enforced as early as possible in the pipeline. For that, you have to implement schema checks, null and range validations, pattern checks, referential integrity lookups, and business rule validations at the ingestion or transformation stage. Over here, you use a quarantine or the bad records store where the invalid records are isolated for inspection and remediation, and emit structured error messages and metrics to monitoring systems so that data engineers can triage the issues quickly. Apart from that, you have to automate the data quality checks in Databricks or ADF data flows and consider adopting the existing frameworks to codify the expectations and produce the human readable reports. Last but not the least, you can also create the SLAs for data freshness and quality and automated alerts for threshold breaches and a feedback loop so that the producers can fix the upstream issues. The next question is, let's suppose your Spark job in Databricks keeps failing with out of memory errors. So how do you troubleshoot this particular scenario? So first and foremost, you can start by examining the driver and the executor logs to determine whether the memory pressure is happening on the driver, the executor, or both. Next, you have to check the size and the number of partitions, as too few partitions cause large tasks that out of memory, while too many tiny partitions can cause overhead. So apart from this, you have to tune the parallelism by adjusting the spark.sql.shuffle.partitions or repartitioning the dataset into a sensible number of partitions proportional to your cluster cores. For that, you can use the persist or cache cautiously and avoid caching very large datasets unless the memory is sufficient. So for joins, you prefer the broadcast joins where one side is small. Otherwise, consider sort merge joins and ensure join keys distribute evenly to avoid the skew. Apart from this, you need to increase the executor memory or cluster size if computations are legitimately requiring it, or refactor the logic to reduce the memory footprint. The next question is, what is Lambda architecture and how you can implement it in Azure? So on Azure, you can implement the batch layer using the ADF plus Databricks to run periodical large-scale batch jobs. The speed layer using the event hubs plus stream analytics or Databricks structured streaming for real-time processing. And the serving layer using the synapse or a store of a pre-aggregated views for dashboard and API responses. The serving layer reconciles batch and streaming outputs so that the queries can read a combined result that benefits from both accuracy and low latency. So over here, the patterns include storing streaming increments in a fast store and reconciling during the batch runs. So while Lambda provides the robustness and correctness, it also introduces complexity and duplication of logic, and many teams prefer Kappa where possible. For example, a retailer might use streaming to surface minute level inventory alerts and a nightly batch jobs to compute fully correct inventory snapshots. The BI layer then merges both to present a consistent dashboard. So guys, with this, we have covered all of the 30 questions and we have come to the end of this session on Azure Data Engineering interview questions. I hope you guys have enjoyed the questions. If at all you have any doubts or queries related to this session, then you can write them in the comment section and we will try to resolve them as soon as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming interview.